Hi, my name is Eduardo Hernández. My ID number is A01709036, and I'm going to present my oral video about the evidence 2, which is the modeling and control of a DC motor. First of all, we need to say about the simulation conducted results. In the left side of the screen, we could see the step response simulation, and in the right hand we could see the white noise that were used in the activity number 2 that were usefully on the final problem situation. It's worth mentioning that the step response was coded on MATLAB with an amplitude of 0.1 and a frequency of 1 rad over S. With the white noise, it was coded with a nice power or a Gaussian ethos. I don't remember so well the name of 0.002 and a sample time of 0.002, which is quite similar as the MATLAB tutorial that the teacher gave to us. By the way, the step response presents a small delay with the estimated, which means that it's not perfect at all, but it follows the signal. The same step goes for the white noise. And now we could see the estimating parameters of the proposed model. For the proposed model, we use the overrated model, which means that we are going to have a lot of parameters, and this means that our system is going to be okay, which means that it follows the least square method. By the way, for the estimating parameters, we use some FIR filters that are determined by the following form, in which we are trying to get the acceleration and the velocity by the least square method. On the right hand of the screen, we could see that we are implementing those filters to obtain the output A and the output B. Sorry. On the other hand, the model validation, we find that the eigenvalues for the white noise and the step response were okay. This means that if the eigenvalues are over 0, it's a well-determined system and it's okay to follow that system. In this case, the eigenvalues for the step response were 0.2 and 2.7, and for the white noise were 0.02 and 0.4, which was quite close to 0. On the analysis results, we could see that the vectors of parameters were equal, so the system is okay. We could see a small summary about the signal parameters, the white noise, so the square signal, the eigenvalues that we already said, and the outputs we get from the step signal and the white noise. As a conclusion, I could say that that was a correct estimation of parameters that can be computed with a vector parameter. Otherwise, the reference signal is followed by a delay in time response, as we already see in this schematic. Another conclusion that I have is that it could be interesting to have a real life experiment, as the teacher said, that implementing this application on a small DC car, but we don't have enough time to implement in real life. Finally, as eigenvalues were over to 0, we have a unique solution, and it's a well-conditioned model.